Hey everyone, and welcome. Today we're going to pull back the curtain on one of the absolute cornerstones of the web. We're going to explore that hidden world that takes a simple static web page and makes it come alive, makes it interactive.
Really think about it for a second. When you load a website, it's not just a flat picture, right? It feels alive. You click a button and things happen. Menus slide out, content updates, all without a full page reload. So how does that actually work? What's the secret engine running under the hood? Well, that's exactly what we're going to dig into.
Okay, so to really get this, we've got to start at the very beginning with the plan for the web page. Let's think of this as a journey from a simple architect's blueprint to a full-on functional building.
So every single web page out there starts its life as an HTML file. And you can think of this file as, that architect's blueprint. It's just a text document, right? It's filled with these tags, like H1 for a big heading, or P for a paragraph. It lays out the structure. It describes the content. It says, put a heading here, and this is a link over here. But just like a paper blueprint, it's totally static. It's a plan. It can't react. It can't change. It literally can't do anything all by itself.
So that's the million-dollar question, isn't it? If the HTML is just this lifeless blueprint, what's the construction process? How in the world does the browser take that simple text file and turn it into the living, breathing website that we can actually click on and interact with?
Okay, so let's get into it. This is where things get really cool. The browser has this incredibly clever way of handling things. It doesn't just read the HTML and slap it on the screen. No, it builds a live, active model of it in memory. And this model has a very, very specific shape.
Here's the magic trick in 3 basic steps. First, the browser just reads the raw HTML file from top to bottom. Then it starts to parse it. It goes through, identifies all those tags, and figures out how they're all nested together. And then, here's the crucial part. It uses that information to build a live, structured model of the page right there in the computer's memory. Suddenly, it's not just text anymore. It's this organized, logical object that our code can understand.
And that live model, well, it has a name, the Document Object Model, or as pretty much everyone calls it, the DOM. The DOM is the browser's internal version of your web page. It's an interface, a go-between, that lets a programming language, usually JavaScript, talk to and control the page. Through the DOM, we can change literally anything. The structure, the styling, the content. It is the bridge that connects our static blueprint to a fully dynamic application.
So, what does this DOM thing actually look like? Honestly, the best way to picture it is like a family tree. Right at the very top, the great ancestor of everything is the HTML tag. It has a couple of direct children, like head and body. Then the body tag has its own children, like all your headings and paragraphs and images. Every single element becomes what we call a node in this tree. And these parent-child relationships are absolutely key for how we find our way around the page.
I love this quote because it just nails the idea of the DOM. Everything we actually see on the screen, the text, the colors, the layout, that's just the ripples on the surface. The real power, the essence of the page and its ability to be interactive, that all lives invisibly underneath in that DOM structure.
So we've got this amazing tree structure living inside the browser's memory. That's awesome. But how do we actually use it? How do we reach into that giant tree and grab one specific branch, or even just one tiny leaf that we want to do something with? We're going to need a tool for that.
And that tool, you probably guessed it, is JavaScript. JavaScript is the native language of the web browser, and it was practically made to work with the DOM. It's what gives us the power to walk through this tree, find any element we want, and then tell it what to do. It's basically the magic wand that lets us control this living structure. Now, one of the most direct ways to find an element is by giving it a unique ID. In your HTML, an ID attribute is supposed to be one of a kind on the page. So a line of code like this one is super specific. We're telling the document, hey, go search through that entire DOM tree and get me the one element that has the ID of para. And here's what happens next. After that code runs, the variable we made, para, isn't just holding a copy of the text. Oh no, it's holding a live, direct reference to that actual paragraph node in the DOM tree. We've effectively reached into the web page, targeted a very specific piece of it, and captured it in our code, ready to be changed.
Now, finding an element is cool, but that's just the first step. The real fun, the whole point of this, begins when we use that reference to start making changes to the live web page. This is where the true power of the DOM shines. Okay, this slide illustrates it perfectly. On the left, you see our original plain HTML. Then on the right, we use that para variable we just captured, and we just tell it para.style.color equals magenta. And boom, just like that, without touching the original HTML file, without reloading the page, the text you see on the screen instantly turns magenta. We've just dynamically changed the style of a DOM node. And it's not just color. We have total control. We can change the actual text inside an element. We can mess with any part of its style, color, size, position, you name it. We can even change its attributes, like changing where a link goes or swapping out an image for a different one. And, maybe most powerfully, we can actually change the structure of the tree itself. We can create brand new elements out of thin air and add them to the page, or just delete existing ones completely. So we can find elements and we can change them. That's huge. But there's one final piece to this puzzle. How do we make these changes happen in response to what the user is doing? This is how we get to real interactivity. The answer is something called events. You can think of events as signals that the browser is constantly sending out when something interesting happens. A user clicks the mouse, that's a click event. Somebody presses a key, that's a key press event. Even something like the page just finishing loading triggers its own event. The DOM is always broadcasting these little signals. And with JavaScript, we can attach listeners to any node in the DOM. This bit of code here, add listener, does exactly what it sounds like. It tells a specific element, in this case a button, hey you, I want you to listen for a click event, and the second you hear one, I want you to run this piece of magical code right here. It's like we're setting a little tripwire, just waiting for a user to trigger it. And this right here is what powers pretty much every interactive thing you do on the web. You know that like button that changes color when you click it? That's just a DOM node listening for a click event and then changing its own style. That sign-up form that tells you your password is too weak as you're typing it, that's an input field listening for key press events and updating other parts of the page in real time. It's all just that simple, powerful pattern: an event, a listener, and a reaction. So when you boil it all down, here's the takeaway. The document object model is what transforms a static HTML blueprint into a living, breathing, programmable structure. It's a tree we can explore with JavaScript, a model we can change whenever we want, and a system that's always listening for what we're doing. It turns the web from just a bunch of pages into a platform for real applications. The web is a living document, and the DOM gives you the power to control it. So the only question left is, what are you going to make it do?